Every equation we've solved up so far in this unit has had one thing in common. They all had exactly one solution. Everything up to this point had one solution, okay? And it says, I want you to think for just a minute, are there any equations, meaning it has to have an equal, that will not give you exactly one solution? Any equations. That means it has to have an equal that'll give you not exactly one solution. I don't want to have any thoughts that we might put down. So when you think about x is less than 4, this is not an equation, right? What is that when you see that less than 4? That's an inequality. And inequalities do have more than one answer. So this is an inequality. X is less than 4. And it has many answers, right? Like x equals 3 is a solution to that. And x equals 2, and x equals 1.79428, and x equals negative 500. All of those are solutions to this. But that's an inequality, not an equation. So on the next page down in your notes, I want you to take a look at that, and we are going to solve this equation. Now, the most confusing thing that I'll have students do is they sometimes want to try and get the add or subtract the numbers first. Don't do that. So when you look at this equation, we want to get the x's all on one side. So it says, what number will work for x in this equation? Keep in mind, this is 1x, and this is 1x. So if I want to get all the x's on one side, I am going to subtract 1x from both sides of my equal sign. When I do that, Angel, 1x minus 1x gives us, so take a positive 1 and subtract 1. What would you get? Take 1 and minus 1. 0. I could either write this as 0x or I could write it as just 0. Plus 1, right, is equal, so on this side, Emily, when I take 1x minus 1x, I could put 0. Does it matter if I put 0 or 0x? Does that matter? What is 0 times x? 0. So this is really 1 equals 2. True or false, Riley? 1 equals 2. Very false, right? 1 is not equal to 2. This is a false statement. And we're going to talk about what we do whenever we come up with a false statement. Now, when you get this false statement, we're going to put a special type of answer. But you still want to get down in that on your paper, I need to see that this came out wrong, that 1 does not equal 2. We know that. And then what you're going to write is that x is equal to no solution. So when we write x equals no solution, someone said, well, how can I check it, Mrs. Thompson? Like, we've talked about those checks, you know, that we've done. How do I check that there's no solution? That means whatever number I pick, and you're going to see this in the video, it should not work. So the easiest number to check, the easiest number that you could always check in this original, okay? The easiest number to check would be x equals, even easier, 0, right? Isn't 0 even easier than 1? So if I go back to this original equation and I plug in 0, I'm going to get 1 equals 0 plus 2 is 2. False, right? Oh, let's check a different one. Let's pick something else. X equals what number? Give me another one, Emily. 3. If I go back and plug in 3 in this equation for my check, right? I have 3 plus 1, which is 4. Is that ever going to be equal to 3 plus 2, 5? This is a false statement. So therefore, I know I plugged in 2 things and it didn't work. And you could plug in 100 things and they don't work, so that's how we know no solution, okay? So we're going to watch this video. There's just a little bit of it, and then they kind of want you to summarize that, and we'll kind of do that together. So when you watch this one, and we are looking at when we get no solution.
What does it mean when a problem has no solution? Well, to figure out what that means, let's look at a couple examples of problems that have no solution. Let's look at x plus 4 equals x plus 2. This looks kind of like a normal equation. But look at what happens when we try to solve for x. Let's move this x to the right-hand side of our equation. To do that, we subtract x from both sides, and then on the left, these x's cancel out, and we're left with 4. On the right, these x's cancel out, and we're left with 2. All of a sudden, we're left with two numbers that do not equal each other. 4 does not equal 2. This is a false statement. If you get a problem like this, where the variables cancel out and you're left with a false statement, you have a problem that has no solution. In this case, no value for x will ever give you a true statement. To see that, let's look at another example. 10 plus 6x equals 15 plus 6x. Again, this looks kind of like a normal equation. But this is in fact a problem that has no solution. No value that you plug in for x will ever make the statement true. To see that, let's pick a couple values for x and see what happens. So let's pick x to be 2. So we get 10 plus 6 times 2, and we want to know if that equals 15 plus 6 times 2. Well, simplifying, we get 10 plus 12, and does that equal 15 plus 12? 10 plus 12 is 22, and 15 plus 12 is 27. 22 does not equal 27. We get a false statement. So that means our value for x, 2, does not work. But what if we pick a different value for x? X equals 6. Let's see.
So similarly, she's going to go through and show you that, and you still get
46 does not equal 51. Another false statement.
So when we are looking at it, and it wouldn't matter, we could start picking fractions, decimals, anything you plug in, it is not going to work, because if we would have solved this and subtracted 6x from both sides, 10 is never going to equal 15. So if I would have subtracted 6x on both sides, 10 equals 15 is a false statement. So when I'm looking at these, that's how I know it's going to be no solution when I look at that part. So what do we want to summarize from our video? When you solve an equation and the variables cancel, right? So we're always going to move our variables first. Those of you that sometimes like to, when the variables cancel, and you have a false statement, what does that false statement maybe look like? A false statement can be just two numbers that are not equal to each other, right? Whenever we have that false statement, like 4 equals 7, negative 2 equals 2, 0 equals 4, anything that is false, we know that these are false statements. If we have a false statement, our answer is always going to be x, or whatever our variable is equal to no solution. There is no number that we know of that if I have a false statement that will be an answer to that. There is no number I can plug back in for the x up here that will ever make 1 equal 2. Never. Yes. So, and then if we're going to start with the distributive property, right? That means I need to get rid of my parentheses by multiplying. What are you going to end up with?
2x.
Okay. 2x plus 6. So let's write that right below the problem. We have 2x plus 6 is going to be equal to 6 plus 2x. So Aiden, we are now trying to get all our x's on one side. Keeping in mind that we always want to try and get all of our variables equal to all of the numbers. So we want to move our variables first. So what do we have to do to move the variable? What would you?
We would have to minus 2x.
Minus 2x. So we're going to subtract 2x on both sides of that equal sign. Now, Elijah, when I'm subtracting 2x on both sides, what am I going to be left with on this side?
0.
0 plus what?
6.
6 equals?
6.
And do you have to write the zeros down? No, I'm okay that you don't. So do we know, is this a true statement? 6 equals 6. This is a very much a true statement. And when we get a true statement, our answer looks different than when it's a false statement. When it's a true statement, it means x is equal to all real numbers. Which means x could be 0, it could be 1, it could be negative 1, it could be negative 500, it could be a positive 5,000, right? What's the easiest one to check? Check 0. And if it works, you might want to check another number, and it should work. And if you wanted to, you don't have to write it down, but maybe you check a third one. So if I check x equals 0, right, since we've been doing so many checks, if I go up here in this parenthesis and I put 0 plus 3, I'm going to be taking 2 times just 3, right? Because 0 plus 3 is 3. And the question is that equal to 6 plus 2 times 0? Is 6 equal to 6 plus 0? Is 6 equal to 6 plus 0? Yeah. What if I put in, give me another number, Dylan.
4.
4. If we try x is 4, in this parenthesis, we would end up with how much? 4 plus 3 is? 4 plus 3 is 7, right? So we have 2 times 7. That's going to be 14. And the question is that the same as we go to this side, and we plug in 6 plus 2 times 4. That's going to be 6 plus 8. Is 6 plus 8 also 14? And if someone else wanted to pick 5 or negative 5 or whatever number you pick, they're all going to work. Every number is going to be true. So when we look at the second video, she's going to talk about the identity, okay? When we talk about the identity, it's very similar to this all real number solutions.
What is an identity equation? Well, to figure out what an identity equation is, let's start by looking at a few examples. 27 equals 27. Well, that's a true statement. This is an example of an identity equation. When the left-hand side always equals the right-hand side of our equation, we have an identity equation. Now, they do get a little bit harder than 27 equals 27. So let's look at another. 15 plus 12 equals 15 plus 12. A little harder, but we can still see the left-hand side is identical to the right-hand side of our equation. This will always be a true statement. And if we can't see that, we can simplify both the left and right-hand sides, and we end up getting 27 equals 27, the first identity equation we looked at. Now, let's add some more operations to it. Let's have 15 plus 2 times 6 equals 15 plus 12. This is another identity equation. But now, the left-hand side does not look identical to the right-hand side. But if we simplify, they do end up becoming a true statement. Again, 27 equals 27. So we have another identity equation, just in disguise. So now that we're getting a feel for what an identity equation is, let's start adding some variables. 15 plus 6x equals 15 plus 6x. Even though it has variables in it, this is an identity equation. The left-hand side is identical to the right-hand side. This means that no matter what value we pick for x, we will always get a true statement. So let's pick a couple values for x and plug them in and see if that's true. Let's pick x equals 2. So we have 15 plus 6.
So this is kind of like how we do our checks, right?
And a true statement. And the first identity equation we looked at. So let's pick another x.
So now she's going to pick a different value.
Then we have 15. What if we have something
like we just did? We picked 2 different values. We picked 0, then we picked 4. Does it matter that these 33 equals 33 is not the same as 27 equals 27? It doesn't matter for that part. What matters is that these 2 things are equal and these 2 things are equal. And that when you eliminate that variable, right, So now she's gonna give you another
6x
problem.
equals 1/2 times 32 plus 12x minus 1.
So I want you to look at how ugly that equation looks on both sides. But if we simplify it, it comes back in that it's still 15 plus 6x, and this is going to be 15 plus 6x. And so if you subtract the x's first, so the biggest thing that I'll see students do is they will not subtract their x's first. What they'll do is they will subtract their numbers first. And if you subtract the numbers, and some of you will get something like this. If you would have subtracted the numbers here, you would have gotten a problem like this, and you would have said something like 2x equals 2x. And when 2x equals 2x, the most common mistake that students will make is they'll say x equals 0. Well, x could be 0, but it could be 1, and it could be 2, and it could be 5, and it could be 7. It's all real numbers. So the biggest mistake here is that people go, oh, I'm going to divide both sides by 2. You can't do that. All your variables are not on one side of the equation. So the key thing I want you to keep in mind is, again, when we are looking at this, so we're going to put down our key information for this next part. What can we summarize? When, okay, we're up here. So when we solve an equation, and when you solve that equation and you eliminate the variables, so in both cases, today's are eliminating the variable first. Get all your variables on one side. You eliminate the variable, and you get a true statement this time. You get, missing some words as I'm writing and talking, you get a true statement. Anytime it's true, 0 equals 0, 4 equals 4, -2 equals -2. All of those are true statements, right? If you get that, then what we are going to say is that x is equal to all real numbers. And anything anyone chooses is going to make it true. Any value that you choose is going to make it true. What would we get?
6x minus 6.
Okay. Is equal on the other side. Elizabeth, what are we going to have as we're multiplying that up?
We're gonna have 6x
6x
minus 2.
Okay. We're going to add our like terms. Okay. So as we're adding those like terms, Dustin, on this side, what are you going to end up with?
You'll end up with 6x minus 2
Minus 2.
equals 6x minus 2.
Now, I just want to show you guys, earlier today, I had someone say 6x minus, and it is minus 2. They got 10. Can you see what they did? Okay. And then they got down and they subtracted 6x on both sides. Do you agree that that would be our next step? Get all the variables on one side. And they got -10 equals -2. And they are on the quiz this next week at the end of the week, and they go, oh, that's no solution. Well, remember, really this was a -2. So if you think it's no solution because this is false, go back and check the easiest check number, which is 0, right? And if we would check this with 0, if you were just going to check with 0, because we know this was supposed to be a -2, right? Which would then make it a all real numbers. But if you would have had it and you thought no solution, and you checked 0, that means you would have had 2 times, 3 times 0, leaves us with just a -3, right? Plus 4. -6 plus 4, that would leave us with -2. Over on this side, if we plug in 2 times and we take 3 times 0, that would just leave us with 2 times -1, and that does equal. So there's no way this could be no solution. So if you think it's a no solution, plug in something and check. And in this case, this one should have been all real numbers. And the reason it was all real numbers is that we had a true statement, right? This was true. If it's true, it's all real numbers. If we are looking at solving the next one, we have 4x minus 12. Andy, on the other side, if we are simplifying and we have 4x minus 12, I want to add my like terms. I want to add the x terms together first. What would you end up with? 8x. And then I would have what as I am looking at that, Zach? 8x, and what are my other like terms over here that you can add together? 4 and
4 plus 8.
okay, which gives us negative 4 plus 8 gives us 4 plus 4. Now, some of you are going, giving me some funny looks. Should this be 8? And here's what I would like some of you to do that are making this mistake. Change your subtraction to add the opposite. Put that negative so that you are really looking at adding negative 2 plus 6x, which then is going to leave us with 4x, not 8x. It is so easy to make that mistake, right, as we are looking at that. So once we have done that, Kaylee, what are you going to do next? We have 4x minus 12 equals 4x plus 4. Minus a 4x on both sides, right? Leaves us with what as I am doing that, Mia? Negative 12 equals, wait, we changed this back here to a 4, right? Did you have 4 back here?
No.
Okay, does it make sense that you're adding negative 4 plus 8? Those were our like terms, okay? This was adding, oh yeah, don't worry, you're not the only one that forgets. But even if you would have had 8, we still would have said that this is a false statement, right? No solution. Oh, I don't think I did it right. Juliana, what's the number you want to check? Easy number. 0. If I check 0, x equals 0, it has to make it either true or false. So I go back up here. 4 times 0? 0. So I'm just left with negative 12. And the question is, does that equal? 6 times 0 is 0. Minus 4, right? Minus 2 times 0, which is just going to be a minus 0, and plus 8. Is negative 12 ever going to be equal to 4? No. So this makes sense that I said no solution. I picked an easy number. I could have picked any number, but that's an easy one. We're going to start adding like terms on this side and on this side. Some of you don't like to add your like terms first. Question. What are you going to end up with? 5x plus 2 8 plus 3x. All right. So now I'm trying to get all my variables on one side. And what am I going to do, Ariana? Subtract 3x. And Haley, if we subtract 3x on both sides, what are we ending up with? Yep. Keep going. Plus. Careful. Yeah. Okay, so I'm looking at that one. And what am I going to have to do on it? 2x plus 2 equals 8. This is like we've been doing, right, for a long time. So we get 2x equals 4. Divide both sides by 2. And x equals 2. Do we know how to check this? Plugging it in. 6 plus 2. Right? Oh, did we do something wrong? Yeah, what did we do? 80.
When you minus from 8, you got 4 instead of 6.
Oh, have any of you ever done that kind of stuff? Just like in your head, you're going really quick. So I just want you to see, when we plug in this 2, would it work, do you think? No, because it should really be, I agree, this should have been 6. So if you catch it, and if you don't catch it, go back. But if I plug in 3, so being really careful for some of those. I mean, some of you, the mistakes you make, it's like you're doing everything right, and then you put down x equals 2, which is not the right answer. And then on the test, you don't do the check and find that it should have been 3 instead of 2, and I have to make off, this is a 5-point question, I gotta take off at least 2 points on that answer, right? So that puts you down to a 60%. So thinking about that. Whereas if I do 3, if I plug in 3 here, 3 times 3 is 9, right? Plus 2, plus 2 times 3 is 6. That means I have 11 plus 6, that's 17. What do I get on the other side? 2 plus 3 times 3, that's going to be 9, plus 6. Oh, that comes out exactly the same. 17 equals 17. I know this is the right answer. It's that quick doing the check. So you don't always have to write it down, but you should plug it in. If we were solving this last one, we're going to subtract 4x from both sides. 7 equals 7. This is a true statement. And so if we are looking at our solution, we are going to say x is equal to all real terms. And if you did the check on that, you keep finding that all your answers are going to keep working as we take a look at that. Okay? So what we are going to be taking a look at is your homework. And in your homework, you are going to do 1 to 17 and number 8 and 18. 1 to 17 odd, and then number 8 and 18. I put that up here also, 1 to 17 odd, 8 and 18. I really want you to look carefully at number 3. In front of the parenthesis in number 3, what number is in front of that parenthesis in number 3? If there's no number there, what is that in front of that first parenthesis? Just the negative? Negative what number? 1. Negative 1. So when we think of this, this is like a negative 1 that you are distributing. Okay? So you got to be careful for that. Number 5. Number 5, this has really been messing people up, all those subtractions. So when I talk about changing subtraction to adding the opposite, that will help many of you out. That means this would be 8n, and I change it to plus a negative 3 times n plus a negative 4. So that when I rewrite that, I need to be really careful when I distribute. Because taking a negative times a negative is positive, but a negative times a positive is going to stay negative. And that's probably where the most mistakes will happen, is in those first couple of steps. And on the quiz on Friday, it's a 4 to 5 point